As I mentioned, there are accessibility requirements. Some of the accessibility has to do with how folks use the approach and use the cabinetry. One of the things that we were made aware of more recently is that there is a difference in the codes between the Americans with Disabilities Act, the ADA, and the California Building Code. They've come a long way. They've made good strides in getting them to be similar, but there's still a few little glitches. So if your client is asking you for ADA, make sure they're not asking for California Building Code requirements, because there's some slight differences, and probably worth noting the difference. One of the differences is that in the California Building Code, this needs to be protected, but not necessarily enclosed. In certain cabinetry of the ADA, they want all those elements enclosed with panels, so that no one can get their feet mixed up with the plumbing parts that are underneath, a fixture. So some of these things you just need to inform yourself about, but I understand there are applications, and each of these are significant, especially given the cost of cabinetry. We want to make sure that our work is done correctly. And that has to do with side reach. There are front approach and side reach approaches that need to be considered. Sometimes your design will permit a side approach that just works better than a front approach. I've had a couple occasions where I couldn't make a front approach, but a side approach was every bit as acceptable. So, understanding that in your code applications is probably a good thing to consider as you're making your design decisions. Transaction tops are pretty important, especially for those who are involved in banking design or retail, and even hospitality. The idea that you have a service bar where someone comes to get a cocktail or some sort of other food service needs to also be provided at a height which is accessible to the disabled. And it can be challenging telling your client that they need to make conformance because you're the design professional, and number two, they are at risk for not meeting accessibility requirements. So we simply don't allow our clients to put in work that isn't that way, especially under our design for our design contracts. Anything they want to do on their own, that's them, but we make it pretty clear our work will always conform. Okay, so as I mentioned, one of the things that we want to think about is that what is the longevity anticipated for the work? If it really is a temporary application, 3 to 5 years may be adequate. The challenge that I found practically in this discussion is that a client may tell you short term, and they get fired, and the new guy comes on and after the first lease is like, how come this stuff is falling apart or isn't as functionally viable as it used to be? So those are just part of the travails of design. It's good to record in the programming how long the cabinetry is likely to need to last. If the person owns the building, they'll probably say for a long time. If it's a short-term tenant, it's a short time. The aspects of durability are important, given the fact that some other person is probably going to maintain these. They're going to clean them. They're going to have to fix them if they are damaged or broken. And, how does that durability of a short-term design play into the idea of replacement costs. Now, I've talked to some designers, and they tend to be more residentially oriented when they take the strategy that they really don't care how much or how long the cabinetry lasts, and they actually prefer it to not last very long, because the client will then need to come back to them and get a new design. I'm not certain I endorse that approach. Uh, the designer says, well, it's past its aesthetic time, and it's now time to get new cabinetry. Well, if you go back to my earlier comments about furniture versus cabinetry, and you've expended a lot of time on the design and it's constructed to last, some of these ideas of replacement are probably difficult for a client to swallow, especially given the cost of design and fabrication. So the idea of aesthetics plays into this. As I mentioned, design longevity has to do a lot with the viewer's eyes. We find some pretty ugly stuff out there, and what I found about the clients that own their stuff, they become what I would refer to as design complacent. Generally speaking, the best design clients are those who've just bought the place, and the first decision they made is all that has to go. And so we get an opportunity to start with a clean slate. But that's not always true. The other thing to understand is that this modular cabinetry is a one and done kind of a deal. I mentioned that it's used a lot. I mentioned that it's cost effective. I've mentioned that it's really a pretty popular solution. The thing I didn't mention to you is that it doesn't like to be moved. The minute you disassemble it, it falls apart like a house of cards. And so you can't just pick it up on this wall and move it over there without having to reassemble it. And then once you've reassembled it, you've just spent a whole bunch of money reassembling and installing old crap. Sorry, old junk. Sorry about my terms, but it's ugly and it's old. My comment is you have to kind of decide that when you're dealing with modular cabinetry, once you decide that it's in place, you're done. If you want new cabinetry over there and you don't want cabinetry there, that's fine. We'll just remove that and we'll build new stuff over there. But understand, it doesn't like this. So the idea of maintenance and serviceability and longevity, those all play together in this cabinetry design process. Okay, so the equipment that serves cabinetry is sometimes just for storing stuff, but other times it's chocked full of requirements. And we're going to see some slides here going forward where I can share some of my experience where it has had to do more functions than it was intended, not intended, but when we first entered the design process, we thought we understood what the client wanted and they wanted more as we got deeper in. So types of cabinetry matter, where it's going, what its base functionalities need to be considered. And again, that's part of that programming process. You should ask those questions early on. It's not about what color and what style. It's like, what do you want this stuff to do over time? So dimensioning becomes critical because, as you'll know, things like appliances have to fit just right, or there's going to be a problem. So these dimensions need to be confirmed and they need to be verified by the contractor as they go about installing the cabinetry or fabricating and then installing the cabinetry and then installing the appliances afterwards. The hardware has lots of parts and pieces. There is an element of MEP, which means mechanical, electrical, and plumbing infrastructure. So what do I mean by that? What would be a mechanical. Well, that would be like air handling or air supply to a cabinetry or to, so we deal with MEP for the whole space, but we deal with MEP very specifically for cabinetry and specialty design. So what are we talking about? We're talking about things that require ventilation. What requires ventilation? Audiovisual equipment is extremely susceptible to heat. Oftentimes, audiovisual equipment is driven by small PCs. PCs give off heat and also are subject to overheating. So we have to create, when we know that PCs are going to be enclosed in cabinetry, we have to provide fans and ports where cool air can be drawn in and hot air can be exhausted out. It gets a little tricky because now we're creating like a chase, which is a gap behind a piece of cabinetry where we can blow air out and exhaust it somewhere. And that might mean that we're exhausting it to the ceiling area above or to maybe a storage closet or an un-air conditioned space somewhere that isn't, but it happens. And as you do more elaborate audiovisual work, and there's a lot of it out there, you're going to be asked to look at that. So another piece would be that electrical. What is powering the computer? What is powering the fan that's ventilating it? What are the low voltage requirements for signal, for data, for control wiring, all sorts of elements that go into this, and specialty wiring and chases for the wiring and management of the cabling for the wiring goes into, some cabinetry. Now, are we talking about kitchen cabinetry and brake cabinetry? No. We're talking about like bank cabinetry. When you go to the bank teller die, which is another term for a bank of cabinets where the teller stand is, there is a horrific amount of equipment behind them. And you'll see in just a bit the list of what that looks like. And then we have that signal piece. Of course, we have plumbing. I forgot that piece. But plumbing is, what you might have in a commercial kitchen, might be in a break room like we're doing, all sorts of elements. And that also includes piping for things like coffee pots, where you would bring in a designated 1/4-inch copper line that keeps the reservoir always full, and that might even have elements of filtration water provided. So you can see we're starting to get into some pretty detailed stuff that just has to do with mechanical, electrical, plumbing. And as I mentioned, there's a lot of control, low voltage stuff that gets put into these cabinets. We're presently involved in designing traffic management centers. And those traffic management centers end up with an entire partition wall covered with screens, with multiple wide flat screen monitors. And we have to hide all the cabling and all that other stuff. And it all has to come through to a specialty console, like a control area where the traffic managers are opening different viewports at all the different places around the cities. So it's a rather interesting undertaking. This cabinetry is more than just simple stuff. So let's move on. Oh my God, that is all the cabinetry. I mean, that's all the stuff that goes in a teller line. Every piece. So when we do bank work, we have to identify by number every piece of equipment that goes in to the teller line. We have to identify where they go, how many there are, their approximate size, their power source, and then notations. And all of this has to be identified in all the plan information. So this is just a design plan, but what you'll find is that a key plan where all those devices are all shown, everything from a credit card reader to your ATM card reader to computers. We have computers down below. Those PCs are right here. The teller sits here. There's all sorts of things going on here. And so you can see how elaborate this information gets to be, and it's all cabinetry. There's very little to do with the conventional idea of break room cabinets which you're working on. So I wanted you to see this so that you would understand that it's more than just what we think it is. There's a whole variety of aspects that are going on. And so, by the way, just a quick note, if you look down here on the right-hand side, you can see there's our teller line requirement for the disabled access that goes in a bank. Anyway, this was a bank that was in that we did up in Upland for Arrowhead Credit Union, and we did a fair number of these. I think in one year we did 13 branches for Schools First. So anyway, we got pretty good at it, and but other cabinetry comes to play, and I have kind of some finished pictures to show. This is a project we did for Whittier Law School. Unfortunately, the school is closed, but the space remains, thankfully. We won a nice national award for this. We were the best woodworking project in America that year, and all this woodworking was our detailing and all. We designed these tables. We designed the placement of the jury stand. We placed the appellate judge workstations. We have the clerk. We have the tellers. I mean the witness stand. I'm going to go to the next slide here. Let's see here. We designed the overhead acoustic system. These are all lighting, and these are all little, they call them puka vents, and what they are is high velocity air vents that are put between. You can see where we had to place every sprinkler head in the exact position we wanted it in all the panels. We had to provide the lighting exactly the way we wanted it. All of this is all false lighting to give the sense of an indoor-outdoor space. We provided all these partitions. And so in that design, we designed for the lectern. The lectern was when the judge, or when you are speaking to the judge or the appealing judge, then you have a laptop. These doors down here open. These elements right here swing up to the side where you can put your laptop. You're provided with a screen that is projected to the judges. They all have screens that they can see, and then a wide screen that is over here for the jury to look at. And you can present information to them through your laptop, and you can control it through the lectern. Now, the interesting thing is that we designed this lectern to pivot 180 degrees so it would face the students, and so they could understand. So the lectern worked not only as a functional courtroom a piece of equipment, but also as an educational element. And so it was on a quasi-lazy Susan, and all the cabling had to be designed so that it would also rotate with the lectern as it moved 180 degrees from one side to the other. Other elements were the prosecution and the defense were given tables where their laptops could be provided, and that same information that was presented at the lectern would be provided also here at the screen of each table. We designed each of these tables with hidden cabling. So the cabling comes down through this wall. to this panel here, to a management system. And it drops, let's see if I can go back a couple bit here. It drops, you can't see it, through that leg right down there. There's a little J box. So there's no cabling that you can see anywhere here. And we designed it so that that floor outlet was specifically designed for this table size and that table application. So the same happens at both locations here. And that each one of the juries, each one of the jurists gets a monitor built into the walls of the jury stand. So you could see just how many things go into these types of elements. In addition, we did the judge's chamber, and we designed the desk, the return, and the bookshelves, and then all the woodwork that goes into the plan. We did the jury deliberation room with whiteboards and a viewing screen in case they needed to be in the room and see and be viewing what was going on in the courtroom, which could be controlled by the judge as to what they saw. So if you go back up here, you can see all these cameras would be directed at different locations in that room. So this room, right, this project right here was $2 million of construction. The millwork, which included all this stuff and all the woodwork, came in at just about $700,000. That doesn't include the seating, that was separate, and it didn't include all the structural things in the wall construction and veneers that we put in. But I just need you to see that these pieces occur in our world, and it takes thought, and it takes good detailing to make them happen as seamlessly as we've tried to do here. And so I put it to you as design students to understand that your clients are going to be looking to you to provide them with the best quality cabinetry as their budgets can afford. And so you may want to think about that. Now, there are some folks that have been in the interior design department who have gone on to be furniture designers. In fact, I'm in touch with a couple of them, and they do very fine work, and they learned a lot from this process and have taken it to kind of new levels. And so I would say to you who are interested, that might be an area of practice that is interesting to you. So moving on a bit, let's kind of get into the brass tacks of what these documents are doing and what they're saying. We start with the notion that we have a standardization of certain expectations, that we believe that the contractor is the professional, and we're the design, and he's the construction professional, and we are the design professionals. And so what we try to do is identify elements that are standard to the cabinetry, and they're very specific. And so we identify contractor notes that we know that they can't escape. We put them right on the drawings, and so that they have no other way but to see them when they're seeing the design, and they can't escape our expectations from that standpoint. We also identify in that information our desire for the types of requirements for it. So, for example, we identify that we want these recessed, low-profile metal standards, and oftentimes they blow us off. The contractor says, "Well, we don't do it that way," and we run into it enough times that we identify hole and peg adjustable standards not permitted. We say it in there because we've seen failure, structural failure in that peg system, and we don't permit it. And it safeguards us from having to go back and reject the work that the contractor has done by them putting in what they like to use instead of what we want them to use. So understand, this is all to protect us and our client and giving them the types of good work that our designs require. So we also have some construction notes, and we tell them, what our expectations are here in terms of the general construction, the cabinetry doors, the base cabinets, the cabinetry shelving, and countertop requirements. Those are just some really simple ways of letting people know what we're trying to achieve with the construction requirements. So we have that information already started in the back of our minds. That's our bias, that's our prejudice towards moving towards a design we can support. And as we develop the drawings, then we can go back to the pattern that we've been talking about for a while. We'll look at the program, we'll look at what the designer has put together, and we'll look at where the design requirements are being imparted in terms of cabinetry. And there we see them identified here in the break room. We go to the enlarged plan and we see what's required there. Then we go down to the interior elevations. We've seen this before. It's not that complicated. We get the views that are needed. We look at our wall sections. We know that, oh, I'm going to have this type of wall. I better put a note in that we're going to put in bracing there, and we're going to bracing overhead, and we're going to provide backing for the cabinetry. So we utilize the wall sections. We add in additional notations for those requirements that give us confidence that our wall is going to be able to accommodate the overhead cabinets. So then we draw our cabinets sections, which you've done last week, and we apply the dimensioning. Just like last week, there's kind of an order. Next, we provide our noting, and as you can see here, we try to be pretty careful with the placement of our guidelines. We're really not interfering with any of the dimension numbers. Yes, we did have to break the dimension line. We had to cross it, but we try to cross it in a very overt way, which makes it simple to understand that that line, which is leading to that leader head, is going to that note. There's very little graphic conflict in what you see so far. So as we do these cabinets, we can now say, hey, this cabinet condition works for 90% of our requirements. But this cabinet section gives us an opportunity to copy this one, bring it over to this side, and apply just what's required for plumbing. So we've done our heavy lifting here. We copy it forward in a new detail here, and almost everything's the same. Most of the noting is very similar. You just copy the note over and edit it, and you can get this detail done very quickly as compared to the first one, which took a little time. So that's why we wanted to do last week's detail, because we wanted to get into some other details by modifying the information. Okay, so that's what I have for tonight.